Om Shri Sai Ram. Welcome to the last session of this chapter, Force and Laws of Motion. Having completed the 2 problem solving sessions, we come to the last problem solving session and we have 3 interesting problems in this session. So before going to solve the problems, I hope everybody get your pen and book and let us solve along. Alright? So let us go and play. So what is the question talking about? An object of mass 1 kg traveling in a straight line with a velocity of 10 meter per second collides with and sticks to a stationary wooden block of mass 5 kg. Then they both move off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate the velocity of the combined object. In this problem, what are the key parameters given, key hints given? Let us segregate that. So, an object of mass 1 kg. So this is one hint. And what the mass of 1 kg, object of mass 1 kg is doing? It is traveling in a straight line. So the velocity is not changing there. It is going with the velocity of 10 meters per second. If it is curving, we say the velocity is changing, keeping the magnitude constant. So here we have already given the velocity is what? 10 meter per second. And also we can say that if the body is moving in a straight line, the acceleration is not changing. If the acceleration is not changing, what we can do? We can use the equations of motion, right? So this straight line gives you the hint that you can use the equations of motion. Now, what it does, it goes and collides with and sticks to with whom? A stationary wooden block of mass 5 kg. So it is going with 10 meter per second. A stationary wooden block of 5 kg mass is there. It goes and sticks. Right? It goes, collides and sticks. Sticks means they are joined together. They are not separated after the impact. So these are the points. Collides and sticks. A stationary, this wooden block is not moving and it is of the mass of 5 kg. Alright? So then they move off together in the straight line. After sticking with each other, they move in a straight line. Again a hint. So after the impact also the acceleration is constant if it is gaining some acceleration. Calculate the total momentum just before the impact and just after the impact. Also calculate the velocity of the combined object. So just before the impact and after the impact, if he is asking us to calculate the momentum, do we know that? Don't we know that? We already know that, right? We may not know the exact magnitude of the momentum, but we always know that when there is no external force acting on our system, then the momentum before the impact should be equal to momentum after the impact. Right? So if we calculate the magnitude of momentum before the impact, before sticking together, then intuitively we can say that the same magnitude of momentum the system will be having after the impact. So one part of the problem we have a clarity. The second thing, also calculate the velocity of the combined object. Right? So after collision, what happens? They move along. That means a new object is formed. Before they were separate. Now they collide with each other and they stick to each other and this form a combined object and it moves. So we want the velocity of this combined object. So let us pictorially see what is happening in the problem. So let us see pictorially. You have a block here, right? So what is we have an object. It is having a mass of 1 kg, right? Now we have a stationary block. It is approaching towards the stationary block of mass 5 kgs. So how it is approaching? It is approaching with a velocity of 10 meter per second. So this is the velocity of this object of 1 kg and it is approaching towards the wooden block, stationary wooden block of 5 kg. Now just before the impact, there are two different bodies, right? So what will be the momentum of this system of object and stationary block before the impact? It is mass into velocity of this object and mass into velocity of this what? Wooden block. We need to sum them up and we'll get the total momentum before the impact. So let us see what is the momentum of the block 1. So the mass of the block, it is 1 kg. What is the velocity? 10 plus what is the mass of the block? Stationary block 5 kg. What is the velocity? It is stationary. It is stationary means it is having no velocity. It is not moving. So the velocity is 0. What is the total momentum of the system now? 10 plus 0. It gives you 10 meter per second. Sorry, it is 10 kg meter per second. Alright. This is the units of momentum, kg meter per second. Now you have this magnitude just before the impact. This is the 10. After the impact, it should be same according to law of conservation of momentum. So just after the impact also, you will have 10 meter per second, 10 kg meter per second as momentum, magnitude of momentum. Now, he also asked us to calculate the velocity of this combined object. When it comes and sticks here, so this all together after collision forms one body. It sticks and these two bodies move together. So they continue to move now in this direction. So let us say it is having v meters per second and this is the vector direction and we need to find out the magnitude of this velocity. So let us find out the momentum. Let us use the momentum equation and find out the velocity of the combined object. So what is the momentum of this body? What is the mass first? 1 plus 5, right? Because they two together form a combined body now. So 1 plus 5 into what is the velocity which we are going to find out is equal to what is the momentum after the impact? It should be equal to the momentum before the impact, that is equal to what? 10 kg meter per second, right? Now V turns out to be 10 by 6, 1 plus 5 is 6. So it gives you 5 by 3 meter per second. This is the velocity of this combined object after the impact. Alright, so whatever given in the question we have found out. First, the momentum before the impact, 10 kg meter per second. According to the law of conservation of momentum, it should be 10 kg meter per second after the impact. If you want to verify that, see 5 by 3 meter per second into what is this combined mass? 6. 3 ones are 3 twos are. That gives you 10 meter per second. Alright. So it verifies you. So initial momentum I mean before the impact and after the impact the momentum are equal. Using that we find out the velocity of the combined object. I hope everything is clear in this problem. Let us see how we worked out. So what are the things given in the problem? What are the parameters given in the problem? Given the mass of the object is m1 is equal to 1 kg, right? Let us take the mass of the object as m1 and that is 1 kg. And the velocity of the object before the collision is v1, that is 10 meter per second. And everything, mass of the wooden block is 5 kg. Velocity of the wooden block before the collision is 0 meter, because as it is not moving, we took as 0 meter per second. So the total momentum before the collision, momentum of the object, momentum of the wooden block. So it turns out to be, as we worked out, it turns out to be 10 kg meter per second. Now it is given that after the collision, the object and the wooden block stick together, right? They stick together. The total mass of the combined system is what? Mass of the object plus mass of the stationary wooden block gives you 6 kg. If you add up, it turns out to be 6 kg. Let the velocity of the combined object is v. We want to know what is the velocity of the combined object. According to law of conservation of momentum, as we discussed, total momentum before the collision is equal to total momentum after the collision. So this statement you need to write while solving problem. You cannot just equate that and conclude and derive the velocity of the combined object. You need to write this statement because of that we are using the next step. So that's why this statement is very useful. So M1 before the collision, this is the total momentum before the collision, and this is the total momentum of the object after the collision. So using that, you can deduce, it becomes 10 by 6. 10 by 6 is 5 by 3. It turns out to be 1.67 meter per second. Now the velocity of the combined object is 1.67 meter per second. This is what is asked in our problem. So as a whole, we need to see the total momentum after the collision. When we also verified that if you multiply this whole mass of the combined object times the velocity of the combined object, it gives you the same 10 kg meter per second which we got before the collision. Alright. So this is the summary of this problem which we have been asked. Total momentum just before the impact is 10 kg meter per second. After the impact, 10 kg meter per second, and velocity of the combined object turns out to be 1.67 meter per second. Alright. So this gives you the first question. This is the solution of your first question in this session. Let us go and see the one more interesting problem, that is this. It is question number 17 in your textbook. Here you have a situation, beautiful situation. Akhtar, Kiran and Rahul were in motor car. 3 of our friends going in the motor car with a high velocity. They are going in a car with high velocity on an expressway when an insect hit the windshield and got stuck on it. What is windshield? You have a mirror, right? You have a glass in front of the driver that we call as windshield. So it shields the wind. So what happens? The insect comes and sticks on the windshield. So the situation is like this. 3 of your friends are moving in car. An insect comes and hits your car on the windshield and sticks to it. This is the overall situation that we have. So based on this situation, 3 of these friends have 3 different observations. Right? Let us see what Kiran has to say. See, Akhtar and Kiran started pondering over the situation. They are sitting in car, they started. So what should happen that made the insect stick on the windshield? They saw the event and now they are deducing what should be the reason behind this. Alright? So Kiran now started the observation. Kiran suggested that the insect suffered a greater change in momentum as compared to the change in momentum of the motor car. Because now he also suggested that because the change in velocity of the insect was much more than that of the motor car. So now the Kiran is suggesting that the insect which is being stuck on the windshield, it is because the insect has suffered a greater change in momentum when you compare to the motor car. This is the Kiran's argument. Now, listening to it, now Akhtar also has his say. What he's saying, Akhtar said that since the motor car was moving with larger velocity, all right, it exerted a larger force on the insect. As compared to the insect, motor car is moving with the larger velocity. All right. So he is suggesting that because the larger velocity is being applied and motor car also is having the huge mass, so he is suggesting that the larger force is acting on the system, on the insect. All right. His statement is, now the motor car is moving. When compared to insect, which is of small size, insect is experiencing a larger force by virtue of its size due to the motor car. So, and as a result, insect died. Now, the third thing, the third friend is there, and he has a different concept altogether. Rahul, while putting an entirely new explanation, said that both the motor car and the insect experienced the same force and the change in momentum and the change in their momentum. What he is suggesting here is, Rahul is suggesting that both motor car and also insect experience the same force. The two experience the same force, and he goes on adding that it also experiences the change of momentum. That means he is saying the change in momentum of motor car is equal to the change in momentum of what? Insect. So these are the three observations we have. All right. Now let us see. We need to comment on this suggestion. Let us see the situation, overall situation, and first have a clarity on the situation, and then let us go to the suggestions which is made by the three friends. All right. For this problem, first of all, we need to understand the system. Here we have our motor car and insect. These two bodies are our area of interest. So there is no external force acting on this system. The two are colliding with each other. So there are internal forces only involved, no external forces. So we can apply the law of conservation of momentum. According to law of conservation of momentum, what happens? Change in momentum of the system, whole system, is zero, right? Why zero? Because the momentum before the impact and momentum after the impact is same. When it is same, what is the change? Change should be zero. So the change in momentum after change in momentum of the whole system is zero here, right? We have the clarity up to here, right? Now let us see the observations what the Kiran made. Kiran made that the insect is experiencing the greater change in momentum when compared to motor car. That is why it is sticking to the windshield. So they had this observation. So the given situation is like this. You have an insect, you have a car, all right. Now insect comes, and what happens when it hits? It sticks here. When it sticks, what happens? The car keeps on moving. Okay. So it gets and sticks, and the people inside it, they are observing. Now, as we know, the change in momentum of the system, our system includes insect and car. Those two bodies include our system. So the overall change in system is conserved. There is no change in overall change in momentum. Now you can see what is the change of momentum of this insect. Previously it is coming in this direction with some velocity. After being hit by the car, it changes its direction and it moves along with the car. That means it is acquiring a velocity that the car is having. In the other words, we can say maybe the car may have lost some minimum velocity which is negligible because it is of huge mass, and that is acquired by this insect, which is negligible by the car. The velocity that is lost by the car, which is negligible for the car, but it is huge for the insect because the mass of the insect is very less. Understood? So it got stuck and the car keeps on moving. So you can see the velocity, the change of velocity of the car is minimum. You cannot say that it is hardly changing any velocity from the observer point of view. But we can easily see that the insect is being stuck and going in the opposite direction along with the car. That means its velocity is changing. So what is which is having the greater change of velocity? Which is having the more change? Only insect is experiencing the change of velocity, right? When compared to the motor car. And the mass of the insect and mass of the car are constant. They are not changing. If you have to change the momentum, what is observed here? Only the velocity can be observed as the mass is constant here. So the velocity here is changing for the insect. So the insect is experiencing the greater change in momentum. Then, which implies that the change in momentum of the system is greater than the change of momentum of the car. Hence, we can deduce that Kiran's observation is more or less correct. Kiran's observation is correct. So let us see. In the given situation, the insect experiences a greater change in its velocity. As we have seen in the diagram, so we can say that the insect itself is experiencing the greater change in velocity. So when you have a greater change in velocity, then what happens? You have a greater change in momentum. Hence, it experiences a greater change in momentum. From this point of view, the observation made by the Kiran is right. Alright. Now, let us go and explore what about the suggestion given by the Akhtar. So what the Akhtar said that insect is experiencing a larger amount of force. What do you mean by larger amount of force? That means when you compare to car, when you compare to size of car, insect by virtue of its size, it is experiencing the larger amount of force. Why it is experiencing a larger amount of force? Because the force exerted by the motor vehicle having the mass very much larger when compared to the insect. Thus, it can exert more force on the insect, right? When the car is coming, you have an insect, it is coming with some velocity and it is having huge mass. It takes some stopping to make it stop. That means it is having the more momentum. Alright. So if an insect is going against it, it will be experiencing a larger amount of force by virtue of its size. Understood? Hence, you can also say that insect is died because it is experiencing a greater amount of force exerted by the car. So compared to the insect, the speed and mass of the motor car is greater, right? So speed is also more, mass is also more of the motor car. Now, second argument is, further, even after the crash, which you had discussed earlier, even after the crash, the motor car continues to move in the same direction. It hardly changes any direction. It continues to move in same direction. This indicates the change in momentum experienced by the motor car is minimal compared to that experienced by the insect. Then, the momentum changed is minimal. As we discussed in the last observation which Kiran has made, we deduced that argument that the momentum which is changing, the momentum change of the motor car is very much minimal as it is hardly changing its direction or it is stopping or something. It is just moving and the insect got stuck in it and it is reversing its direction. Insect is reversing its direction. So the greater changing momentum is experienced by the insect. Right? Now, if you see if you have a greater change in momentum in a particular time, that means the rate of change of momentum is more. If the rate of change of what do you call as a rate of change of momentum? Is nothing but force. Right? Hence, the force experienced by the insect by virtue of its size exerted by the motor car is what is high, hence it dies. So, Akhtar's observation is also right. Now, let's go back to our Rahul's observation. What Rahul has observed is, he says that when the insect is hitting the windshield, he's saying that the force is experienced by the both objects, insect and also the motor car, are equal. And he also adds that change of momentum of the motor car and of the insect are equal. That means momentum before the impact of the insect, momentum of the insect after the impact, how much change it has is equal to the change of motor car. Before, some momentum it has before the impact, some momentum it may have after the impact. So this change are equal, which is what Rahul is claiming. Alright, so let us go and argue whether his observation is right or wrong. Rahul's observation is partially correct. Why it's partially correct? He said that the force experienced by the insect and the motor car are equal. Yes, it is equal because if you see the Newton's third law of motion, you see that action is equal to reaction. Right? If the insect is applying the force on motor car, thus motor car in turn applies a force on what? Insect in equal magnitude and opposite in direction. Alright? So the the force experienced by the motor car by the insect is equal to force experienced by the insect by the motor car, exerted by the motor car is equal. That is what this law says. As per the third law of motion, force exerted by the insect on the car is equal and opposite to the force exerted by the car on the insect. So his first statement is right. The force is same on both. Right? And the second statement, he further goes on adding that momentum change is also same. If the momentum change is same, then what it contradicts? It contradicts our law of conservation of momentum. Right? After the collision, some velocity this car has to reduce. That velocity this insect gained. That means there is some loss. That loss may be minimal to this car because of having the huge mass. But this insect is having the less mass. That velocity which the motor vehicle lost, it may be huge for this insect. So it experiences the greater change in momentum. So the change in momentum is greater here, change in momentum is lesser for the motor car. That is what Kiran suggested. Right? Kiran's suggestion was correct. Now here the change in momentum is equal for both motor car and the insect are same. This claim is wrong. Right? Why it is wrong? Because it contradicts our law of conservation of momentum. So, however, Rahul's statement is incorrect. Why it is incorrect? Because the momentum gained by the insect is equal to the momentum lost by the motor car. So, it is according to the law of conservation of momentum. So, if you consider that case and compare it to Rahul's argument, it implies that the system, which is what is the system? Our motor car and insect together forms a system. That system experiences a change in momentum. Right? If both momentums are equal in magnitude, when you talk about their change, what happens? It changes the magnitude of magnitude of momentum of the system together, right? That cannot happen. This cannot be right, because the momentum of the system before the collision is equal to momentum of the system after the collision, right? In order to have this momentum before the collision, after the collision, the magnitude of the momentum should be equal, then it should vary, because you don't have the same mass here. Mass of the insect is different, mass of the motor car is different. Velocity of the motor car is different, velocity of the insect is different. You don't have any symmetric situation here. It is asymmetric situation. When you have asymmetric situation, the momentum change cannot be equal for both the object after the collision. I hope you got this answer correct. If not, go back and once again go through every detail what we have spoken till now. Alright. So with this we concluded the second problem. Now the last problem of this session is how much. This is the last problem, and it is very interesting problem. It looks like simple, but if you think little deeply, you will have more solutions for this problem. How much momentum will a dumbbell of mass 10 kg transfer to the floor if it falls from the height of 80 centimeters? Take its downwards acceleration to be 10 meters per second. So, in this problem, we have been given that we have a mass of 10 kg and it falls from a height of 80 centimeters, and we also have been given that it is going with the downward acceleration of 10 meters per second square. Alright, so the situation is like this. You have a ball object, dumbbell here, and the mass of this dumbbell is 10 kgs. Mass of the object is 10 kgs. Now it is falling down. It is falling down with what? With the downward acceleration of 10 meters per second. So we will derive this. We will derive this magnitude in our next chapter called gravitation. As of now, just you consider that this ball is falling down with the constant acceleration of 10 meters per second. What does this mean? If you have a ball, initial velocity of this ball is 0 because it is free falling. Now, you have a ball. After 1 second, what happens? It is gaining a velocity of 10 meters per second. Right? Up to 10 meters. One more 10 meters per second. One more second, it becomes 20 meters per second. So, for each second, it is gaining the velocity of 10 meters per second. Alright? Now, we are asked that how much momentum does this dumbbell is transferring on the floor, if you have a floor here. Alright? So, to find out this, we know the mass. Let us use the equations of motion, right? Because we have a constant downward acceleration here. So the acceleration is not changing. As far as the acceleration is not changing, we can easily use the equations of motion. So what is the height given here? Height given here is 80 centimeter. That means 0.8 meters. So this is the height. This is the height we have. We know the height, we know the initial velocity, we know the acceleration. We need to know the velocity at this point just before impact. Alright, if you know the velocity here, we can know what? We can easily able to know the momentum, right? Momentum is nothing but mass times velocity. We know the mass, we need to know the final velocity just before the impact, so that we can able to tell, okay, this much momentum it transferred on the floor. because it is having that much momentum at this point of time. It carried that momentum and it transferred to the floor after hitting it. Alright, so let us calculate the final velocity here. So as we know that u is 0 here, the given u is 0, we need to find out. A is given as 10 meter per second square and the height is already given, height is 80 centimeters, right? Now using these equations, can we calculate final velocity? Yes, we can calculate the final velocity using third equation of motion, right? V square minus u square is equal to 2as. You know the initial velocity u is equal to 0. We want to know the final velocity v. V is equal to 2 into what is the acceleration given here? 10, right? So let us take downward as positive direction, upward as negative direction. So what it will be? Plus 10 meter per second square, right? 10. And what is the distance from here to here? It is 0.8 meters. So it is 0.8. Now v square turns out to be 16 and v is equal to 4. What is 4? Meters per second. So the final velocity of the object is 4 meter per second, right? So when it started here, it has 0 meter per second. After 80 centimeters, it gathered a velocity of 4 meter per second. So when it gathered a velocity of 4 meter per second, it has a momentum of what? Final velocity, the velocity it is having at this point, times the what? Mass, m into v. So mass is 10 kg, velocity is 4. So final momentum P is equal to 4 into what is it? This is the mass. That turns out to be 40 kg meter per second. So this is the final momentum that object is transferring on the floor. So it is having a dumbbell is having 40 kg meter per second just before the impact. After the impact, what happens? The dumbbell stays still, right? It does not have any momentum. The velocity is 0 after hitting the ground. That means where the momentum has gone, it transferred to the floor. So this is the magnitude of momentum that has been transferred by the dumbbell on the floor. So let us see the working and then explore an interesting concept. So what are the given? What is the data given? Just write it down. Mass of the dumbbell 10 kg, distance covered by the dumbbell 80 centimeters, which means 0.8 centimeter. This step is so very important because the students usually often make mistakes without converting they use the same data given in the problem without conversion in the substitution in the problem. Then what happens? You will get a different answer. When you get a different answer, the whole process, the whole problem will be wrong. Maybe the concept may be correct. If the magnitude is wrong, then you are not seeing the question properly. You are not solving the question properly. So make sure that all the units are in the same system, either CGS or MKS. Usually we follow SI. So make sure that it is well converted before substituting in the formula. So the acceleration in the downward direction is 10 meter per second square. And initial velocity it is not given, but it is a free fall, right? Nobody is applying. So it is under the acceleration of 10 meter per second. That means the initial velocity we can take it as 0 meter per second. According to third equation of motion, we have already worked out v square minus u square is 2as. That turns out to be v square is equal to 16. That is equal to v equal to 4. Hold on to this. I'll come back. So final velocity of the dumbbell is what? 4 meter per second. Now the momentum with which the dumbbell hits the floor is what? M into V. That is 10 times the velocity of the dumbbell. 10 times, 10 is the mass times the velocity is what? 4 meter per second. So the magnitude becomes 40 kg meter per second. So this is your final momentum of the what? Final velocity means final momentum of the what? The dumbbell. So that much momentum is being transferred on the floor when it is hitting the floor. Right? If you look this problem a little bit deeper, you can say, here you see v square is equal to 16. Up to here, everything is fine at this stage. For those of you who are very keen learners, just observe at this stage. V square is equal to 16. Ideally, v should be what? V should be is equal to plus or minus 4. Right? Now we are taking only plus. Why we are not taking minus? See, every answer that we get, every solution that we get while solving has a reason. And we need to understand why we are not taking minus 4 and why we are taking plus 4. Because plus 4 gives you the velocity, the event that is occurred afterwards. While solving this, if you see the time also, if you go and see the time, then the time it took from the topmost point to come on the floor, it will also have two different values. For example, see, S is given as 0.8 is equal to ut plus half at square, right? What is u? U is 0. As we already know, it is because it is a free fall. What is remaining? Half at square, right? Half into a you have as 10 and time as t. We don't know, t square. So here you can see t square is equal to what? 5, 0.8 by 5. Something 0.8 by 5. So here you also have the two values of t. Right? What does the two values of the time mean? That means one you have the minus value, one you have the positive value. The positive value of the time suggests that the event will happen after this much time afterwards. The negative time says that the event could have been started before this much time before. Understood? As long as the problem is concerned, it is saying that you have a body here and you have a floor here. So the mathematics doesn't care about how it came. It gives you the solution for all possibilities. It came here. How does it come? It doesn't matter. Maybe this event might have occurred before, and also it may come after this. Right? You have a body, you have a ball on the floor. If the event we are considering afterwards, that means the moment the ball will come on the ground with the 4 meter per second velocity. When it reaches here, it gains 4 meter per second velocity. Now, when we consider minus 4 meter per second velocity, that means before this much amount of time, that ball could have traveled to this point and decreased the velocity to 0. So minus 4 tells you that before the event, plus 4 will tell you the velocity gained after the event with that much amount of time. So we are only consider that the velocity after the event. So the final momentum here we got as 40 kg meter per second. Hence, the momentum transferred by the dumbbell on the floor is 40 kg meter per second. So, in this chapter, we have completed the most important problems and interesting problems. What I have learned in this chapter? In this mechanics, all together, using motion and also force and laws of motion, we have covered equations of motion and 3 laws of motion, and also law of conservation of momentum. And we touched a little bit, informally we touched a little bit on free body diagram. Alright, so having covered all these concepts, it is left to you to play and explore more. I hope you enjoyed this session and try some more problems. And before concluding, Sai Ram.